Okay, so the topic we are gonna study today is levers. What is a lever? A lever is a rigid bar that rotates around a fulcrum. Means that if this is the rigid bar and this is rotating around a fulcrum, so this rigid bar, this is the lever. And there are three components of the liver in human body. We have muscles, we have joints, and we have bone. Bone is the rigid bar, joint is the axis, and muscles apply the force. Types of levers. Now we have three types of levers: first class lever, second class lever, and the third class lever. Let's see first class lever. Fulcrum, it is between the force and resistance. As we can see here, the fulcrum, it is between the force and it is between the resistance. Some examples are seesaw, scissors, pilers, and crowbars. In all these examples, the fulcrum, it is situated in between the force and the resistance. Now let's see this seesaw in detail. How come it is the first class lever? When you sit on one end of the seesaw and your friend is on the other end, so the pivot or the fulcrum, it is between. You are pushing down means the effort and you are lifting your friend load up. In human body example, agonist and antagonist muscles acting on opposite sides of a joint. What are agonist muscle? Agonist muscle is a muscle that contracts to create a movement. An antagonist is the muscle that relaxes or lengthens to allow the movement. These both muscles work in opposition across a joint. For example, neck extension at the atlanto-occipital joint when you are nodding your head. Here, the fulcrum is the atlanto-occipital joint where the skull meets the spine. Effort or force, it is provided by neck extensors muscles like the trapezius muscles and the splenius capitals at the back of the neck, and load is the weight of the head at the front. How it works: when you tilt your head backwards in extension, the extensors muscles contract and pull the head up. These muscles are the agonist. At the same time, the flexor muscles at the front of your neck, like the sternocleidomastoid, relax. They are the antagonists in this movement. The joint in the middle acts as a fulcrum, make this a first class lever. Now let's come to second class lever. Here, the resistance, it is between the force and the fulcrum, means that the resistance, it is in between, and the force and the fulcrum, it is on the sides. For example, wheelbarrow, nutcracker. Now let's see the wheelbarrow in detail. Here, the fulcrum, it is at the one end, the wheel. The load is what's inside the barrow, it is in the middle, and the effort is applied at the other hand handles. Because the load is in between the fulcrum and the effort, it is the second class lever. When you lift the handles, and put the effort, the wheel acts as a pivot and the fulcrum and the weight inside the wheelbarrow is the load in between. It gives a mechanical advantage, making heavy loads easier to lift. Human body example. It is rare but occurs during muscle bone function during eccentric contractions. For example, eccentric contraction during plantar flexion when lowering the heels, when you are walking down the hill or slowly lowering from tiptoes. Here the toes metatarsophalangeal joint acts as fulcrum. Here the load is the body weight over the foot, and the effort or the force is the calf muscles that can be gastrocnemius and the soleus performing an eccentric contraction as they slowly lengthen to control the heel. Why it is the second class lever? Because the fulcrum is at the front, the load is in the middle, and the effort applied by the calf muscles pulling the heels are lengthening to control the loading. This matches a second class lever where the load is in between. Third class lever. Here the force is in between the resistance and the fulcrum. As we can see here, the force, it is in between the resistance and the fulcrum. For example, shovel or a broom. Here the fulcrum is at the one end, like hand at the bottom of the handle. Effort is applied in the middle for pushing. The load is at the other hand, that can be a dirt. Why it's the third class lever? Why it is the third class lever? Because when we are sweeping, one hand holds the end, the pivot, and the other hand pushes in the middle, puts the effort, and the third at the bottom end is the load. This gives speed and control but not much force advantage. In human body example, we have some muscle bones lever systems like biceps at the elbow, patellar tendon at the knee, medial deltoid at the shoulder. Let's see biceps brachii during elbow flexion in detail. That can be when you are lifting a dumbbell. Here, the fulcrum is the elbow joint. Here, the effort is provided by the contraction of the biceps brachii inserting on the radius. Here, the load is at the far end of the lever. The biceps apply the force between the elbow and the hand, and the elbow joint is the fulcrum. So, fulcrum, effort, load. This is the classic third class structure. When you lift a weight by bending your arm at the elbow, your biceps contract and pull on the forearm. The insertion point of the biceps is close to the elbow joint, meaning the effort is applied close to the fulcrum. This setup sacrifices mechanical advantage for speed and range of motion, which is why third class levers are common in the body. They allow quick, precise movements, even if they require more force. So summary table: in first class lever, fulcrum is in the center. In the second class lever, load is in the center. And in the third class lever, effort is in the center. Hope you like my video. For such more videos, subscribe to my channel.